Today we are going to talk about how to create a modular Android application architecture. Obviously, the first question we should ask ourselves is, why do we even want to do it? And there's a couple of reasons, so we'll quickly go through them. The first one is scale. So if you're writing an application with you and maybe with your friend, like, it's easy. It's not going to be too big. Both of you can know everything about the application. But as your application grows, you're going to hire more developers, and it will be very hard to work on the application without stepping on each other's toes. So what you can do is, you can create these modules where people can specialize in certain sections of the application, and they can work independently without slowing down others. A similar benefit is maintainability. So if you have a monolithic application like this, where you have all these layouts, and when you reach to dozens and hundreds of layouts, it's going to be very hard to look at it and understand what's going on. Instead, if you group those layouts based on what feature they are in, now it will be so much easier when you're looking for something, you will find it there. It will never be a long list of weird names. And that has a new added benefit, which is faster incremental compilation. So if we go back to the previous example, where you have this monolithic application on the left, and the modularized application on the right, and we change the same file in both of these scenarios, this is how much it's going to invalidate. This is how much Gradle needs to do. OK, check all of that group, run more tasks, and those tasks will have more inputs, and they will take longer to run. The smaller they are, the faster it is. Similarly, you can also run your continuous integration service faster. So if you have an application where we have properly modularized, we have a couple of small modules, and there's bigger modules that depend on them, and the application at the end depends on all of them. If you made a change in this, let's say, module 5, which test do you need to run to make sure that change is good? The answer is very simple. Only that one, and anything else that depends on it. This is the only test you need to run. You don't need to run all of your tests because the other modules cannot be impacted. Well, you might say, well, we don't have incremental CI. Many people are in this situation, and it's the same situation for Android X. So this is what we do in Android X development. We wrote a plugin that discovers the dependency graph, and then this plugin looks at the Git history, figures out which files are changed, which modules include that files, and then discovers which modules are affected by those changes. And then it only builds the tests for those modules, and our test runner runs only those tests. You can go and check it from this URL. We will add it to the notes, and you can retrofit for your own build. Before we did this change, our pre-submit in Android X was taking around 2 hours. After we made this change, it now takes from 10 to 20 minutes, depending on what you have changed. Last but not least, is also good for business. When you modularize your application with app bundles and dynamic delivery, we will talk about it later, you can significantly reduce your install size. From Play Store stats, we know that many of your users drop between the time they clicked on install to the time they start using your application. So the smaller your application, the less it takes, and you will have just more signups. Similarly, it also lets you test different things. Let's say you have an application that has a camera feature, and your PM comes with this idea, well, like, I found this amazing library. It's 10 megabytes, but takes beautiful photos. Now, you don't need to argue whether it's good or not. You can implement it as a dynamically delivered feature, A/B test it, see if it helps, and then distribute to all of your users. This gives you a lot more flexibility in trying out different things in your application without hurting your users.
Modules, modules, modules. You'll be hearing a lot these words in this talk. So what kind of modules are we actually talking about here? Well, we're going to talk about Gradle library modules, but also dynamic feature modules that are part of the Android app bundle packaging concept. So let's see how we define what we put inside a module. How should we modularize? So we can do this either by feature or by layer. So let's start with feature modularizations. Let's see what module types would work for features, and also what are the different options for packaging that we would have, and what are the implications of these. So we would have a base app that's just an Android application. And then we could have a module that's an Android library. The app would depend on this library. So this means that the app would have access to the code and resources from module 1. But the other modules can be dynamic feature modules. And dynamic feature modules can be used for on-demand code loading via dynamic delivery. And they would also depend on app. So this means that the module 1 and module 2 would have access to the code and resources from app. But then app would declare these modules in their bit.gradle file as dynamic feature modules. So what's important to remember here is that app doesn't actually depend on module 2 or module 3. This is actually the main restriction of the feature modules in the app. So even if the app doesn't really have access to the code and resources, I think this allows the option to have the on-demand delivery of feature modules. So through dynamic delivery, users can download and install dynamic features on demand. Modules that have on-demand turned off are by default added as part of your APK, of the one that's downloaded or installed on your device by the users. And if you enable on-demand delivery, it means that you, as developers, also need to manage the download of the module from Google Play Store. Then shared code and resources would be part of the core library. And a nice benefit of on-demand delivered modules is that you can depend on a third-party library and only download it when you're actually downloading that module. So this means that you're able to decrease your APK size even more. OK, but how do we decide what is a dynamic feature module and what not? So for this, I like to look at the 80-20 principle that says that 80% of your users are using 20% of your app. So look at the other 80%. Look at those features that are not part of your core flow of the app. Things like expert features or paid features that can be downloaded later. Similarly, you can have a feature like onboarding that can be afterwards uninstalled later. So here, the on-demand will be false, and then you would be able to clean up a bit the space. But how about something like an about screen? This is something that's not part of the core flow of the app. Should this be on-demand or not? Should this be a dynamic feature or not? I think, rather, this is a better candidate for an Android library, because what you want is to have an instant access to that about screen. It's something small. You want to make sure that you have a good user experience. You don't want the users to wait for this. And also, I don't think it's worth having all the trouble that dynamic features modules bring for something simple like about. In Plaid, one of our sample apps, we took a different approach. So Plaid is a news application. It aggregates data from 3 different sources: Designer News, Dribble, and Product Hunt. And each of these sources have their own presentation and business logic. So what we wanted to do is to have the possibility of on-demand delivery. So we wanted to be able to download these data sources whenever we need them. We wanted to be able to add in the future others. So this means that Designer News and Dribble are dynamic feature modules. But then we looked at something like Search and About. These wouldn't benefit from on-demand delivery. So we left these as library modules. Now let's see how we can modularize per layer.
Thank you. So one option is to modularize your application based on features. Another, albeit simpler option, is to use a layered modularization. So what do I mean by this? So let's look at the played application again that Florina talked about. Let's look at what kind of user features we have and what technologies we need for them. So we said we have stream of news, so we need a place to process them, we need API clients to fetch them, and we also need a UI that shows those feeds. Now we have multiple news providers, so we need probably different web service clients. We want to have custom styles because we want to style these news based on their source. So we need a custom styling library. And we need authentication because we want people to be able to vote and comment on these stories, which means we also need a post UI where people can see the details of a story and the comments associated with it. So We'll take a bottoms-up approach here. We start with the database, using room, I guess it's a good one. And then inside this database module, we have our entities and data access objects. And then we have a web service module on the side that depends on retrofit and a JSON parser, because all of the APIs we use here use JSON parser. We can use Moshi. And it also has data transfer objects. We will talk about them later. Now we have our repositories. This is where most of our actual business logic lives in. And then we have things like user repository or Dribble repository for stuff coming from Dribble. On top, we have our user interfaces, which just talk to these repositories to display whatever is necessary. Last but not least, we said we also need a custom styling library, but it can be a module just by itself because it's not really related to our application. Now, let's see how we can benefit from this kind of layering. One option is isolation. So there's a little crash course here. When a module says I'm dependent on another module, it can either say API or implementation. Now, I know it's confusing, so I'm going to quickly explain them. When a module A says I have an API dependency on module B, that means all of the public functionality provided by module B is also provided by B. So my dependents can access module B's public API. But if it says it's an implementation detail, then modules that depend on A cannot see B. They shouldn't know about B. And this gives us some power. So let's get a practical example where we have an API that returns us a list of comments. Each comment has some data inside it. And we have a user object about who made that comment. Now, if we want to move this to our database, we want to persist it. So we create an entity. It's our comment entity. Inside that, we have an ID, we have the text, and the user. Now, if you look at this entity, there's a little problem here, because probably we have the same users commenting all the time. So it's not a very good idea to keep that information inside the comment object, because if a user changes their profile photo, you need to go and update all of them. Another option we can do is just create a user table, but then we cannot do it because our server sends the user inside the comment object. There's a very easy solution for this kind of problems. We can make this a data transfer object. A data transfer object is specifically designed to get the data from your backend to a format that your application can understand. Now we can have a separate object for our database. We'll call that one comment, and that one can have the user ID. We'll also have a user table. But now, why did we do this separation? Let's see how it plays in practice. So we'll go through the scenario. Our repository calls the web service to get the comments. We get the list of comment DTOs. Then the repository divides this into two. It divides them into users and comments and pushes them back to the database. Now let's look at how we declared our dependencies now. Our web service says, I have an implementation dependency on retrofit because repository doesn't need to know about that. It doesn't matter. Similarly, database says I'm using room, but no one else needs to know about it. Repository says I'm using the web service as an implementation dependency because UI doesn't need to know where the data is coming from. But then here we say we have an API dependency on the database. So in this example, we are doing it because it's very likely that the same object we are using in the database is what we also want to use in the UI. Or might be pulling these objects as different POJOs from the database for our UI. So we need to set it as an API dependency now. Which is fine, but not that fine, because now our user interface can see the entities. We want that, but we don't want our user interfaces to have access to the database, because if they access the database, now we lost the layering, because they know where the data is coming from. They shouldn't. That's the theory. Now, there's two options you can do here. You can be fine with this. If someone writes a code that makes a database query in their UI layer, you're like, no, you shouldn't do this. Or you can take this one step further. We could create another module that's for all of our common value objects that we use across the application. Some of them might be entities. Some of them might be just regular value objects. And in your database module, you can have other entities and your DAOs. Now the repository can say, I have an API dependency on this value object versus just an implementation dependency on the database. Once we do that, our UI only has access to the classes we want it to be able to access. So we get finer control over them. Another nice benefit of this kind of modularization is testing. So we say we have a repositories and we have a user repository here. Whoever is writing user repository can also create a fake implementation of it. A fake implementation has the same API, probably extends or implements the user interface, but provides additional functionality. So our user repository is a good user function, a get user function that returns the live data of a user. The fake one has the same functionality, but it can have other things like put this user or put this user as an error. These are the things you will need when you are trying to write your UI tests. Once we have that in our application, we can make the main UI component depend on the actual implementation, and the test UI component depend on the fakes. This will make it very easy. This is a much better approach than trying to mock it, because when you mock something, you don't know how it is supposed to behave, versus the person who is writing the repository knows how it will behave, so they can create a much better fake for you.
OK, so we looked at how to modularize by feature and by layer. Feature modularization brings you encapsulation and the possibility of on-demand delivery. Modularization per layer brings you isolation, allows you to isolate your third-party dependencies or the layers in your app, and also brings structure to your app. But you can also mix and match, apply a feature and layer modularization. But if you're starting from a monolithic application, we think that the first step that you could do is to start with a layer modularization. And then, as time goes by, you can go more towards a feature modularization. So let's see how to work with dynamic feature modules, because even if this enables on-demand delivery, it also brings a few challenges. So the first one is with navigation. So let's say that our about feature is inside a dynamic feature module. So from our main activity that's part of app, we need to navigate to this about activity. What we would usually do is just launch an intent saying, hey, start this about activity. But I said that app doesn't have a reference to the code from about. So this means that you'll get a compiler error. To overcome this, what you can do is just use intent, set class name, and pass the component name. I know, this looks a bit strange because it's hard-coded. And indeed, it means that when you have to refactor your code, you need to make sure that you're also updating this string. If you're working with fragments, you have to do something similar. You would have to use reflection to create an instance of the fragment. And with fragments, there is an extra thing that you need to do. You need to make sure that you also exclude the fragment names from ProGuard. We know that this is not nice, but in the same time, we know that there are no runtime performance hits for this. And we also want to help improve this process to make navigation between feature modules as natural as possible. So we are working on this as part of the navigation Jetpack library. OK, let's see how we can discover dependencies in our app. Let's take the following example. We have a search activity that is part of the search module. And we want to be able to search for news in Designer News and Dribble. So for now, let's consider that these two feature modules, Designer News and Dribble, are already downloaded, so are part of your app. But still, Designer News, Dribble, and Search are three completely different modules. You don't have references. You don't know how to use, how to call, which classes you should call. And we also want to make sure that in the future, if we add another data source, we can easily plug in that one as well. So we kind of want somehow search to depend on Designer News and Dribble. So what we do is we use the common core library that is shared between all of these. So here, we're defining a data source interface. And then Designer News and Dribble implement that interface. And Search holds a set of these data sources, so it knows how to query the data. But things are not that easy, because when we want to instantiate the Designer News data source, we see that it depends on other things. It works with a story repository that, on a row, works with a remote data source and a local data source that also work with services, share preferences, maybe even room. So there are a lot of classes that you need to instantiate when you want to create an instance of Designer News data source. So how do we do this? In general, what we actually want is to have one single entry point for creating the designer news data source. So we would have something like a data source provider interface that would define in core, and a get data source method that would allow us to retrieve it. And then in designer news, we would implement this data source provider and then building the dependencies. In search, we would need to provide these set of data sources. So we would check whether a feature is installed, and then if it is, we try to get to create an instance via reflection of that data source provider. And then we get the data source from the provider and add it to our set of data sources. Alternatively, you can also do this via a service loader. And you can check out both versions, the reflection and the service loader, in one of the samples that we released recently. OK, so we said that we would need to create the dependencies. And chances are, a lot of you here are also using Dagger. So let's see how you could do this with Dagger. So if you're using Dagger, you most likely use another component that you define in core. So then, in your designer news data source provider, you would need to create the graph for that component, and then from that graph to actually get the data source. OK, so we said that for the first case, our dynamic feature modules were already installed. But what if they're not? What if, when we're launching the search activity, we only have designer news, and we want, whenever Dribble was also installed, to also start searching for data in Dribble? So we start from the same case. We still have a data source that's implemented in designer news and Dribble. But now, having just a set of data sources is not enough. So we also use live data to make sure that we're also notifying whatever classes are interested in these data sources. And then, for convenience, we wrap this inside the registry. So PlayCore gives us the possibility to react on modules that have been installed. So this means that we can register a listener, and then this listener also tells us when a module was installed. So this is the point where we're getting the data source, as we've shown previously, and then we just add it to the registry. Now let's see how we work with databases.
Thank you. So when you start modularizing your application, you're going to face this problem with databases. I'm like, where do I put them? And there is no perfect answer for this. So we're going to go through some examples and options we can do here. So one option is the easy one. You can just have one database for all of your application, which is what you usually do when you have a monolithic application. Or you can create a core database for the common functionality, and then have separate databases for your features. And they also have some plans with Room, which are not ready yet, but I want to talk about them, because fun. So how do we do it if we have just one database? It's very easy. So we have this database module that depends on Room. We put all of our entities and all of our data access objects into there. Very simple. And then you have modules depending on it. Now, if you have an architecture like this, the nice thing is it is super simple to understand. You don't need to guess where do I put it. You just put it there. And then you have only one database connection to maintain. And then you can just keep it open for the duration of your application. Database connections are not cheap. So if you have multiple ones, you need to be closing them. And this also gives you the possibility to share tables. Like if you have queries that's across modules, you can easily write them in this common shared database. Now, the problem with this approach is there's absolutely no isolation between your modules. So description of a post for one of the modules might be significantly different than the other one. So now you need to rename these tables to make sure they don't conflict. It will be hard when you look at the code base. And even worse, let's say you use the dynamically delivered features that Florina mentioned. Now, even if you are delivering the feature dynamically, you need to put all of its entities and data access objects into this core module that ships with the app. So it creates a awkward division between the module with its entities and the rest of its code. That's not something you want. OK, so let's go back to the other extreme, where we create a database per module to achieve the perfect isolation. So you have this each database, so authentication module has its own database, feed has its own database, and the post has its own database. If we do that, we reach our goal. There's perfect isolation between all of these modules. But now we have many database connections that we need to maintain. We cannot keep it open for the duration of the app anymore. We need to start tracking when we are querying the database and make sure to close it when we are not using it. Also, if you want to write a query that touches two different databases, you simply cannot. I mean, SQLite allows you to attach databases to each other, but there's some difficulties with that. And beside that, you will find yourself implementing SQLite in your own Kotlin code. And one of the other problems is you will end up duplicating some data because they will probably have shared data, and you will just be writing it into both of these databases. Of course, an obvious iteration after looking at these two is, why don't we just do a hybrid approach? If you go back to this example where we create the module, a database for each module, and you look at the feed and the post databases, they probably have the same data. You know, the feed shows them in a list, and the post UI shows them as an individual one with comments. So it is more data, but you can basically put all of them into one database. Now they can share the data, and it will be a lot more efficient, while we can keep the authentication just by itself. Now, this option is great because it gives us full flexibility, but the problem is it's very flexible. So you always find yourself, all right, where do I put this one? Should we merge these two, or should we keep them separate? And you're always going through those decision points, and it's always a challenge as part of your application. Now, for Room, this is an important problem that we want to solve. Similar to how we want to solve the dynamic library navigation in the Jetpack navigation component, we want to provide support for multi-module applications in Room. So this is what we want to do. We are going to allow you to find smaller databases in these modules in a way that you can let them depend on each other. So Room can merge them at runtime, while in your code base you can get the isolation benefits. And then this way, because we know which database depends on which other database, we can let you create queries in your DAOs that query across multiple databases. And we want to support on-demand delivery so that even if your entities and DAOs look like they're inside the feature module, when it gets installed, Room will basically merge them depending on how you set it up. Unfortunately, it's not available yet.
So one thing we haven't discussed yet is whether these modules should be Android-free modules or not. And I think there are advantages and disadvantages to this. So the first thing is that you could reuse the modules. You could use something like Kotlin native and then share that library between multiple platforms, between Android, iOS, between mobile and backend.
Well, that's a great idea, but make sure you have that use case. So if you start let me remove all the Android from this code base, so maybe 3 years in the future, we're going to have cross-platform, how do you even know that code is going to survive 3 years? So don't do it if you don't have the use case.
Having Android-free modules means that for that module, we just need to implement JUnit tests. That's all. We don't need to implement these Android instrumentation tests that can be quite slow.
It's true. I don't disagree. But writing an Android application that doesn't use the Android framework is a challenge. You will find yourself duplicating things or start mocking things in your tests. So if you are doing it just for the testing benefits, don't. Just use Robo Electric. And you can get the same speed benefits without trying to reinvent the Android framework yourself.
Then, in general, when you read about architecture and the theory around architecture and clean architecture, one of the things that you see, one of the guidelines, is that you should minimize dependencies to make sure that you're not depending on classes that you're not using. This also means that you're able to do a clear separation of concerns, making sure that your business logic doesn't depend on any UI classes, for example. It allows you to build better abstractions.
Abstractions are great, I agree, but you need to be careful. Just like as you add more and more abstractions, your code base will get more and more complicated. So as you add these abstractions, always think about it, like what benefit am I gaining from this? So the TLDR of this talk is you go back home after I/O and start rewriting your application in modules. No. No, we are not done yet. So it's our responsibility as the Android team to show you these options. But it's your responsibility to learn them, investigate, see if they work for your use case, and then decide for your use case. These are options. These are not rules. There's no like perfect solution that someone figured out. It depends. And also, when you're doing this kind of changes, you should always compare your short-term costs with your long-term benefits and make a proper decision. Speaking of cost and benefit, the modularization or these abstractions graph usually look like this. So once you start doing like some modularization, maybe the layered one, which is like super easy to do, you're going to get a lot of benefits out of it without spending too much time doing it. But then if your project grows, maybe you can start looking at like modularizing by features, spend more time in that kind of things because you need to scale the team. But then if you are in the like world of Google's, Facebook's, Uber's of the world, then we spend a lot of time these things because we have hundreds of engineers trying to work on the same code base. So it's okay for us to spend this time. So if you're in a similar situation, yes, go as far as you can go because you're going to gain something. But if you are not in that world, don't try to do it. Because your users will say, oh, this application is very well architected. No, no one will ever put that 5-star comment saying that. They're going to say things like, this is very sleek, it's very robust, or this application has great features, I love it. So all of these things we're talking about are a means to an end. We want to have happy customers. We want to have more of them. So when you make your architecture or modularization decisions, always keep your customers and users in your mind. Thank you.
Thank you.